Well, my name is Mark Ennifson. I'm an application engineer with Bross Company. We're an industrial automation supplier here in the upper Midwest. And today I'd like to talk with you about micro PLCs and some of the motion capabilities that exist today. Many people aren't aware that even on a 10, 14, or 20 point PLC you can do motion control. So on board we have 4 axes of pulse and direction, or clockwise, counterclockwise pulse control that can be used for stepper or servo motion. It's rated at 100 kilohertz and it's very effective for motion applications. So in this video I will show you a little bit more about hardware. I'll also go into a very quick overview of the product lineup from the brochure, show you where that product sits and some of those capabilities. We'll go into the programming tools, show you what a typical wired or wiring interface looks like, and then finish up with a product demonstration. Okay, so from the product standpoint, looking at the lineup here in the lower right, you've got a CP1L, a CP1H, a CJ family known as a CJ1 or 2, and the large rack CS1 platform. So we're focused in this discussion about the CP1L, although the CP1H will come into play. Okay, the motion capabilities are outlined in a number of places in the brochure. The lineup, though, on the hardware side is what I'd like to review at this point. There's a 10 point, 14, 20, and then a 30, 40, and 60 point PLC. Additionally, if you need greater capabilities, you can jump up to the next family, which is the CP1H. These offer up to a 1 megahertz pulse stream capability. There's units with or without analog. As you would fly through the product line, more detail will be presented in some of these motion capabilities, and here is illustrated an integration with the Smart Step 2 hardware that I'll be showing in a few minutes on the demo. There's also high-speed counter capability should you need to close the loop or be doing some other form of positioning. Perhaps it's a Modbus integration out to inverters. There's a pseudo closed loop capability there as well. Okay, so for the programmer, a key point of interest is going to be with regard to the instruction set for manipulating motion. In the programming manual, section 5 is dedicated to this pulse output function, and these charts are pretty informative about covering the detail here. What I'd like to share with you just as a good quick review is that the instruction, the subset of the instructions, are about 6 or 8 in total. You've got a speed command for doing velocity control. You can use that with an acceleration and get a ramp. You can change speeds discretely on the fly and do ramping and curve control. The positioning commands are really done with a combination of some pulse commands and so forth. There's some more detail on how to stop motion if it's running under a speed command, and or doing that with a ramp down. Scanning down, you'll see the pulse output for more doing positioning. Okay, and you can use a pulse command and or a combination of a pulse command and an XL command to get ramping, to do more of a trapezoidal move, and complex trapezoidal moves can be done very nicely with the pulse 2 command. This is the one I prefer, actually, all in one instruction. You can create a step frequency if you're trying to get through resonance on a stepper motor. You can then in the next operand set your XL, your overall, or your speed, your overall distance, a decel rate, and that instruction does it all just in one PLC block. A very nice instruction to keep things simple and compact. There are a few other explanations in here, changing speed in steps, blending to change with an XL, and things of this nature. So there's 5 or 6 pages in here that do a pretty good job of explaining this. This will be in the ops manual for the CP1L. Another nice function with this micro PLC family is that in the programming environment, in the project tree under settings, you can go in and manipulate how the homing functions work. And really it's just a simple selection of going through first from an operations manual and choosing the time chart that most accurately represents the homing routine that you'd like to do. So there's a couple pages in the ops manual that show you that, some good detail here, and really it's just a matter of going in then in your programming environment, choosing that setup structure, and then very simply from the ladder code just firing one instruction, which is called the origin instruction. It can be used for origin search to first establish a home, or an origin return depending on the operands that you set in it. So an origin search would establish homing after a power up to get you a known position. The origin return is just a different operand in that instruction that returns to home once you've been doing some positioning or other motion. Okay, in this next section we'll review the wired interface to accomplish this. One thing to be aware of is that the I/O layout changes depending on the model that you have. So in this illustration we're looking at a 10-point controller. You've got your pulse output capabilities labeled here, the 14-point. You'll notice that it changes as you go. If I scroll down through the locations here with regard to origin input points and so forth do change. The table below here will show the correct locations for wiring your pulse interface, depending on if you're doing pulse in direction versus clockwise, counterclockwise. So some detail there that the programmer or the project person will need to consider. Again, with the inputs, your homing inputs and locations of things here do need to be taken into consideration. So key point here is that as you're buying the I/O system, if you're buying a 20-point PLC and you're wanting to do 2 axes of motion control, you're probably going to be using 4 points of output and probably 2 to 6 inputs depending on what kind of limits you might have on actuators. So that will take away from usable I/O, and it's as you might expect, but just a good key point there nonetheless. Okay, so as far as the product demonstration goes, I've got one of our demo boards here. I'll just explain the hardware involved. Here's the topic product, the PLC. I've got a 20-point PLC. Inputs wired in up here just to simulate clockwise limits, homes, and things of that nature. Power supply and a breaker for power to the board. I've got a serial comm going out to an Omron HMI that I'll use for demonstration purposes. But as far as the motion goes, that's done here. So here's our Smart Step 2 servo pack. It's wired from its CN1 breakout to the output of the PLC. And the motor's here, of course. So a servo pack wired through breakout to the PLC and HMI. So on this basic screen, just to start, I've got some jogging here. You can see my motor motion, stop, clockwise, stop, counterclockwise, stop, change my input speed accordingly, and you can see much slower speed. If I go to the next screen, I'll go back here just a second, stop motion. This is a relative move. I've got variables to push in accel, decel, target velocity, distance, and a start frequency. This is that pulse 2 instruction I mentioned. And just a real simple trapezoidal move here. If I go to the next screen, I've got an input from the HMI to do 4 different positions in a basic demo form. I've got the pulse 2 instruction running there. Because it is doing absolute moves, I will do an origin search. You may have seen the servo motor move there. And if I trigger this, then it will run through and show bar graph performance to achieve the 4 positions that we've got. Okay? And in the final section here, I will go in and show you a little bit about the ladder code and the programming environment, and that will conclude our session. Okay, in this last section we'll do a very brief review of some of the instructions that were used. We're looking at CX Programmer here. The project tree consists of many of the typical things you would see in a PLC program, and my code sections are in through here. I'd like to go back just for a second though and talk about that subject of homing. That's set up back here and under the PLC settings, and that can be found in under the pulse output control, and here you see the various options that you have for setting the homing routine. This correlates back to the time chart patterns that we reviewed earlier on. So this is set up here, and then it's really just fired from an origin instruction, which I'll show you in a minute. For the basic speed control, here's an example of a speed control instruction. This is for jogging, this is for clockwise, counterclockwise. We've got a port specifier for which axes of motion, an output mode, pulse and direction versus clockwise, counterclockwise, and a speed that comes in from the HMI. So clockwise, counterclockwise, jogging. The position control, here's the pulse 2 instruction. You just specify which port, again, which axes, some control data, and then a block of 5 or 6 registers that set up the whole trapezoidal move. The sequence that I ran for you just a few minutes ago under the absolute move with 4 positions, I've got to establish a home position first, and that's done with an origin command. There's an origin return, and here's an origin search. Okay, so you can just see that the control data is a little bit different. I've got some move data in here to set up a beginning block for the move sequence, and then I've just got a pulse 2 instruction that takes in different move values. So I've just got 3 or 4 rungs of code that are required to move that sequence of 4 moves. Really very simple. Down on the bottom here you'll see a grouping of items here that are related to monitoring what's going on with the motion system, and these are very helpful. So as I would go and run motion, you can see my present value here, contact here, or rather a bit for when my motion's in progress, and some different things that way. So a number of very feature-rich status bits back, and just a very nice simple way to approach a motion application if it's not too complex and needs to accompany a few I/O. This concludes my video. I hope you've enjoyed it, and that's it. Thank you.